All right, looking at lesson 12, we have the relationship between absolute value and order. So I'm going to pick some random numbers. We'll take a look at how they order each other, right? So I'm going to go with negative 13, 8, 6, 5, negative 3, negative 7, and 3. So when we go ahead and do this, we're going to take them, it says record it from least to greatest, so that's from smallest to biggest, right? So the smallest is going to be the biggest negative, so negative 13 will be the biggest negative, then the next biggest negative is negative 7, then negative 3. I'm going to put check marks just so that I don't forget which ones I did. Then the next, so now we're going least to greatest, so smallest number to biggest number. The smallest positive number I see is the number 3. Next smallest positive I see is the number 5, then 6, and then 8 is the largest positive number that I see. So it says write an inequality statement relating the ordered integers in the opening exercise. Below each integer write its absolute value. So I'm going to go ahead and use that same order, and I'm just spacing it out a little bit so we can see and put an inequality, right, which means Al the hungry alligator one way or the other way, right, in between them. And let's start with the easiest of them. If I compare 6 and 8, Al the hungry alligator eats the bigger of the two numbers, right? So he would be eating towards the 8. Same thing between a 5 and a 6, he'd be eating to the right. And you'll notice that all of the numbers to the right are larger than the number that's directly to the left of it. Between a negative 3 and a positive 3 is larger. Between a negative 3 and a negative 7 means would you rather owe somebody $3 or owe somebody $7, right? So in both cases you don't have money, but in the first case you owe $3. That would be once you get paid a certain amount of money, you have more left over to keep to yourself once you pay your debt, right? So Al should be eating that way. And then below it, we're writing the absolute value of it. So absolute value, remember, absolute value of a negative number is just that number. So absolute value of negative 13 would be 13. Absolute value of negative 7 would be 7. Would be 3, that would be 3, that would be 5, that would be 6, and that would be 8. Remember, we have an absolute value of a positive number like 12, right? It's just that number. So it's just the magnitude or the distance away from 0. It doesn't tell you whether it's positive or negative. Below that it says circle the absolute values that are increasing in numerical order and their corresponding integers. Describe the circle values. Rather than circle them, I'm going to just talk about what's increasing. Well, increasing in order. Starting with this one here, these are all increasing as we move this way. So it's all of my original positive numbers. Rewrite the integers that are not circled, or all the other numbers, right? How do these differ from the ones you circled? These are all, so that's these guys here, these are all my negative numbers. And then it says rewrite the negative integers in ascending order and then their absolute value in ascending order below them. So ascending means smallest to biggest. So again, the originals were negative 13, negative 7, and negative 3. And then their absolute values were 13, 7, and 3. So 3 would actually be the smallest number of its absolute value. This is my absolute value. This is my original or integer. So 3 was the first one, 7 is the next one, and 13 is the largest of them with absolute values. And then describe the order of the absolute values and how they compare to the negative integers. So as we look at this, I'm going to write this up here. We're talking about the negative integers versus the absolute value of those negative integers. And those are, the mathy term is, and they are an inverse. It's a fancy way of saying they are flipped, right? They're flipped or it's an inverse. Whichever one's the biggest is the smallest, whichever one's the smallest is the biggest when we order it from least to greatest or greatest to least. And looking at that a little further, as we look at this here, we have a little diagram, and so we're actually drawing just the arrow or the magnitude of how big it is. So this one would go to 3, so this should be 3 long. This one would go to 4, so this should be 4 long, and the last one should be 5 long, and then we're going to do the same thing here. 1, 2, it's in the different direction, so we're just drawing the absolute value or the magnitude of the line. The negative part means that we're just drawing it to the left. The positive part means we're drawing it to the right. And as we look at this, it says as you approach 0 from the left, so starting from the left as we go this way towards 0, the integers, that's the numbers itself, negative 5, negative 4, negative 3, negative 2, negative 1, the integers increase or get bigger, right? Again, a smaller negative means that you have more. But the absolute values of these, the absolute value of -5 would be 5, absolute value of -3 would be 3, absolute value of -1 would be 1. Yeah, so the absolute value of these integers decrease or get smaller. And this means that the order of the negative integers is blank, the order of their absolute values, right, is flipped, or again, that math term is the inverse, or is the opposite, right, of their order of absolute values. And as we look at this here, all I'm going to do is I'm going to start by just taking all my negatives and put them in the left. It says separate the numbers into positive rational numbers, negative rational numbers, and 0 in the top cells. Order doesn't matter. Then we'll write the absolute values of those. So we'll start with that top chunk up there. So all of my negatives, I've got a -4.5, got a -6, a -1.5, a -6.3, a -4. I'm just looking at all these and I'm putting check marks as I go to make sure I didn't miss something. And I have a -9.25. -9.25. And then I have the positive versions of these. So that's all the ones that don't have check marks yet. And of course, 0 is my chunk in the middle there that says 0, right? So then I have all the other ones that don't have check marks. So 2.1, I have a positive 0.25. That's a decimal there. I have a 3.9, a 2 3/4, and a 3.99. Right, and that's all the ones that don't have check marks minus the 0 that's up there with the arrow. Absolute values means I'm just going to take each one of those and find the absolute values. The absolute value of -4.5 is just 4.5. Absolute value of -6 is 6. Absolute value of -1.5 is 1.5. And so each one of these absolute values is going to be that same number. It's just the positive version of it when we're looking at our negatives. So I've got a -4, so that would be an absolute value of just 4. And then the last one is an absolute value of 9 1/4. And the absolute value of positives don't change. So I'm just going to say that it's the same as above, because we don't have to put it in order right now, right? So it's the same as above. It's all those same numbers. Absolute value just means that that's the amount, that's the magnitude. C says order each subset of absolute values from least to greatest. So now we're saying from least to greatest. That's smallest to biggest. So right now we're doing absolute values. So we're looking at these two pieces here. And so smallest of those two pieces that I see is 1.5. And then the next smallest that I see is a 4. Then a 4.5. Then I see a 6, a 6.3, and a 9 1/4. And that's all 6 of those. And then on the right-hand side, same thing, absolute values. So we're looking at from smallest to biggest. The smallest one that I see is a 0.25. And then I see two 2s, a 2.1 and a 2 3/4, so 2.1 and 2 3/4. And then I see 2 of the 3s, so I have a 3.9 and a 3.99, right? 3.9 and 3.99. I'm just making sure I didn't miss one. 1, 2, 3, 4, 5. Okay, cool. 2 3 4. So 3.9, 3.9. 3.9 is like the same as like 3.90 versus 3.99. I know it's a small amount of difference, but if I was giving you the amount of money and it was either $3.99 or $3.90, you'd pick the 99 cents because it's more money, right? So that's why that's the largest. And order each subset of rational numbers from least to greatest. So now we're not doing absolute values, we're doing the rational, so we're doing the actual numbers itself. Well, the rational numbers means it's going to be the biggest negative first, is the smallest amount. So -9 1/4. Then -6.3, then -6, then -4.5, -4, and -1.5. And on the opposite side, remember, absolute values don't change anything when you have positive numbers. So this is going to be the same order. And then on the bottom it says order the whole given set of rational numbers from least to greatest. So that's going to be the same as D. So it's going to be same as above. right? Because zero's in between the negatives and the positives. So I don't need you to rewrite that. I just need you to understand that. This next part says find a set of 4 integers such that their order and the order of their absolute values are the same, right? So if we're talking their absolute values and the order of the original number is the same, that means these are going to have to be positive numbers, right? Find a set of 4 such that the order and their order of their absolute values are opposite. Well, that's going to have to be negative numbers. Non-integer just means, so remember integer is whole numbers, positive, negative, and 0, right? So negative, 0, and positive are my integers, right? But we're talking whole numbers or no decimal / fraction, right? The non-integer means it includes, so it's all the same stuff, but it includes decimals and fractions, right? So that's what this is. So same exact answers, right? If their order and the absolute value order are the same, it's got to be positive numbers. And if the order and the order of their absolute values are opposite, it's got to be negative numbers. And that's what I need you to understand when we look at numbers and then their absolute values of those numbers, is when we look at ordering them from either least to greatest or greatest to least. So we put them in order of their size or how much it is. If they're positives, then the numbers and the absolute values don't change. If they're negatives, then the numbers and the absolute values flip. They're opposite, they're inverse, they go the other direction. Right? The smallest becomes the biggest, and the biggest becomes the smallest. And E says order all of your parts, all your numbers from A through D in the space below. This means you should be order 16 of them. Again, all I really need you to know on this is that positive order doesn't change, and negative order flips or is an inverse or opposite. Okay, that's all I need you to know, and then I'm happy enough with that. Okay, and we are off to problem set.